Right, so today we're going to go over some homework problems from 10.1, 10.2, and 10.3, just questions people have asked, and a couple other ones I want to go over. And then we're going to look at 10.5. So let's get started. All right, first let's go over some problems that people had. We'll start with 10.1, number 20, so you can dig out your homework or you can open your book to page 568. So it says a fuel storage tank has a diameter of 50 meters. Just do one of my crude drawings here for a cylinder. All right, so here's my fuel tank. Diameter is 50 meters and the height 75. If a gallon of paint covers about 45 square meters, so 45 square meters per gallon of paint, about how many gallons are needed for 2 coats? So I got to cover the thing twice. And it says the exterior and the top. Now my guess is that some of you got this wrong because you didn't read the directions carefully. Some of you probably tried to paint the bottom of the fuel tank, even though the directions say just the sides and the top. Most people aren't going to flip a fuel tank, especially of this size. I mean, 50 meters, that's of a diameter, that's roughly the same size as half of a football field. Okay, so you're not going to be flipping this on its side so you can paint the bottom. You're just going to have to live with the idea that the bottom's not painted. All right, so let's figure this out. First, we got to figure out this. So we're looking at surface area of the side, the lateral area, and then the top. So to find the surface area, if you unrolled this cylinder, so to speak, so if you took like a piece of paper, okay, so let's say this is my cylinder fuel tank, okay, just like this. So it's in a cylinder. What happens, so here's my cylinder, right? What happens if you take a cylinder and you unroll it, so to speak? Okay, you get a rectangle, right? So here's my cylinder, like this, right? My lateral area is a rectangle where the height, or the width, sorry, of my rectangle is actually the height of my cylinder, and the length of my rectangle is the circumference of the cylinder's base. So with that in mind, just draw this rectangle here. So we said if the lateral area, so this is our lateral area of this cylinder, the height of the cylinder becomes the width of my rectangle, and the circumference, so that would be 50 pi, is the length. So looking at, then let's do 75 times 50. Oops. So the lateral area of my cylinder is 3,750 pi meters square. Then I have to add the area of the top, which, if the diameter is 50, the radius is 25, so that's 625 pi meters square. So 25 squared, 625, right? So you got pi r squared. So then all together, so I add my 625. So my area that I'm painting is 4,375 pi, which is approximately 13,744.47 square meters. So now a gallon of paint covers 45 square meters. So I got to divide this by 45, and that gives me 305.43 gallons of paint. That's to do one coat, but I have two coats, so I multiply by 2, so that gives me 610.86. Now, obviously, we're painting here. If you've ever done any painting, you're not gonna you're gonna round up, right? You can't buy a point. I don't think you can buy anyway a 0.86 gallon worth of paint. So you're gonna have to buy at least 611 gallons of paint, and probably more, but at least 611 gallons. So that's your answer for 10-1, number 20. All right, the next question I wanted to go over is 10-2, number 9. Okay, so this one, it says a football field measures 120 yards, so 100 yards long, and then the end zones are each 10 yards. 110 yards by 53 1/3 yard. About how many times as large as the area of a football field is the lateral area of the pyramid of Khufu? So if you look back in the reading on section 10.2, you find the area in example 1, the lateral area of pyramid Khufu. And so they find that as 86,400 square meters. Okay, so in the question, we're also told that 1 yard equals 0.9144 meters. So we have to do some conversion here. One way to do this would be to convert these dimensions to meters. We could also convert this, the 86,400 to yards, to square yards. So 1 square yard is equal to 0.9144 squared, meters squared, right? We just square everything. 1 squared is 1, yard squared is yard squared. 0.9144 squared is here, meter squared, meter squared. So 0.9144 squared is, so 1 yard squared equals 0.8361, 2736 meters squared. Okay, so let's figure out this here. So we're going to go 120 times 53 1/3. You stupid thing. All right, 6,400 square yards. So in a football field, there are 6,400 square yards, but we want to compare that to meters squared. So what we need to do is we need to take our 6,400, we got to multiply it by our this number here. Oops. Sorry. Okay, so this is our how many square meters are in a square yard. We're going to multiply this by how many yards we have, and that's going to give us 5,351.22 meters square. So our 6,400 yard square is 5,351 meters square. Now, looking back at our lateral area for our pyramid, the question was basically how many football fields could fit into the lateral area of Khufu's pyramid. We take 86,400 divided by our 5,351 number, and we get 16.15. Okay. So about 16. All right, 10 to number 16. In this one, it says you got a 90-degree sector is cut. Sorry, I was looking for my cone net. I have to make a new one. So a 90-degree sector is cut from a circle with a radius of 18. So we're just going to pretend here's my circle. We'll just cut out my 90 degrees here, approximately. Might be a tad more than 90. Okay, so, but we're going to say that was 90 degrees. And it has a radius of 18. Find the area of the shaded region. So the shaded region is a picture in the book, but the shaded region is basically this whole piece here. Find this area. So we can find the area of the whole circle, because we can do, if the circle was whole, then it would be pi 18 squared. Which is 324 pi. But we are missing this 90 degree. We're missing a quarter of the circle. So we got to multiply this by 3/4, because we're missing a quarter, but we have 3/4 left. So 324 times, well, I think, yeah, we can, sorry. 324 times 3/4 gives me 243 pi for part A. Then part B says if the shaded region is folded so that basically the ends meet there, the lateral surface of a cone is formed. What is the lateral area of this cone? So they're saying if we do this, right, which we did in a previous video, we get a cone. And so the idea there is that this area here, what we just figured out for part A, is the same area as the lateral area of a cone if we were to fold the ends together. So that's also 243 pi. And then for part C, it says that from this point here all the way to this point here, sorry, this point here, okay, that's a major arc of my circle, forms the perimeter of the base of the cone. What is that length? So here's my cone, right? So notice that my arc length, going back to my circle, my arc length of 3/4 of my circle is equal to the perimeter of the base of the cone. So for part C, I'm going to take 3/4 times the diameter of the circumference of the original circle. So that would be 36 pi, right? Double the radius of 18 is 36 times pi, circumference of the circle. So if I do 3/4, that's 9. So we'd get 27 pi as the distance from here all the way to here, which is also the base of my cone, the perimeter of the base of the cone. So then part D says, use your answer in part C to find the area of the base of the cone. So here's my cone. We're trying to find, if we had this base, what would the area of that base be? So this gets a little tricky. So I'm going to start part D up here. Okay, so if the circumference of the base of my cone is 27 pi, so the circumference of the cone is 27 pi, I know that the circumference of the cone is equal to 2 times the radius times pi. So I know that has to equal 27 pi. So I'm trying to figure out what the radius of the cone is. This is the radius of the cone. If I took 2, I don't know the radius of the cone, but if I knew it, and I took 2 times radius of the cone times pi, I would get 27 pi, the circumference of the cone. Hopefully you're following that logic. So I can solve this though. So I can divide each side by pi. Those will cancel. And I'll get 2 times the radius of the cone is 27. So divide both sides by 2. The radius of the cone is 13.5. So now it says, what is the area? So I just need to do pi 13.5 squared. So, oops. And that gives me 572.56 approximately, or 13.5 squared is 182.25. So 182.25 pi. So that's the answer we're looking there for part D. Okie dokie. So that's 10.2. And let's, so I guess I didn't use this. So let's do 10.3. We got a couple questions here, starting with number 18. Okay, it says a cube has a volume. So the volume of a cube is equal to 29,791 cubic centimeters. What is the surface area? Okay, so we know the volume, we want to know the surface area. So the volume formula for a cube is the side length cubed. So we know S cubed is 29,791. The surface area formula is 6S squared. So in other words, if we can find the side length of the cube, we can put it into this formula. So we can find the side length by taking the cube root here of both sides. So 29,791 to the 1/3 power. It's the same as the cube root, if you remember from a previous lesson. So we get 31. So the side of my cube is 31. Now I'm going to plug it into this formula. So the surface area equals 6 times 31 squared. And that's 5,766. This is both these, this problem here and this one here are good problems to put a star by. That's why we're going over them. So, okay. A new paper here. All right, let's look at 10.3, number 19. So it says a cube has edges x centimeters long. So we got a cube, the edge is x. And another cube has edges 4x centimeters long. So we've got a bigger cube. So here's my small cube. You can imagine maybe that's a cube. Now, so we said that's x, and then you've got another one that's 4 times the side length. Again, I'm sure you're drawing much better quality pictures on your own paper. Okay, so this is 4x. All right, and it says so for letter A, it says find the ratio of the total surface area of the smaller cube to that of the larger cube. So the surface area of this cube is just 6x squared, right? Because you take the surface area formula, put in x. And down here, it's a little tricky with your algebra. So it's not 6 times 4x squared equals 24x squared. That's not the way to do it. Algebraically, if the side length is 4x, I always use parentheses, you got to square the whole side length. And up here, you're just squaring x and not the 4. That's wrong, because you're not squaring the whole side length, just the x part. You got to square the 4 and the x. So you get 6 times 16x squared equals 96x squared. So they want the ratio. They want the ratio of the small to the large. So the ratio is going to be 6x squared over 96x squared. That's my ratio. And obviously we can simplify that. X squared over x squared is 1, right? So that's going to cancel. And then 6 over 96 is 1 over 18. Sorry, 1 over 16. Mental math failed me there a second. 6 times 16 is 96. 1/16. And what you'll notice is that this side length is 1/4, right? So this is 4x, this is x. So their side lengths are in a ratio of 1/4. Area, their surface areas are in the ratio of 1/16, which is 1/4 squared is 1/16, right? Area is a square of length. So now for part B, it says, what is the ratio of their volumes? So the volume of my smaller cube is x cubed, right? And then for my larger cube, so smaller, my larger cube is not, don't make that mistake what we just talked about, right? It's not 4x cubed like that. No, it's 4x cubed, where the cubed is going to apply to both the 4 and the x. And 4 cubed is 64. X cubed is x cubed. So 64x cubed. So the ratio then is x cubed over 64 cubed. Again, the x cubes will cancel, but remember we've got a 1 here, 1x cubed. So our ratio is 1/64th. And that should make sense because we had our sides are in the ratio of a quarter, the areas of 1/4 squared, which is a 16th, and the volumes 1/4 cubed, which is a 64th. Okay? And then 10.3, number 20. This would be so much better if you could ask me questions back if I'm not explaining something about it. All right, it says 1 inch equals 2.54 centimeters. What is the volume in cubic centimeters of a cube with a length of 1 inch? So if we have a cube of 1 inch, the volume is going to be 1 inch cubed. The side length's 1. So then what is the volume in centimeters cubed? Well, if my cube is 1 inch on the sides, then it's the same as if it had a side length of 2.54 centimeters, right? Since 1 inch is 2.54 centimeters. So to find the volume, we just take 2.54 and cube it. Oops. And so that's 16.387064 cubic centimeters is the same as 1 cubic inch. And then part B, so that's part A. Part B, 1 cubic inch is how many cubic centimeters? So that's basically asking the same thing. 16.387064 cubic centimeters. And so you can, those of you who know anything about engines, I don't know a lot about engines, but so for example, a famous truck engine really is the 350. So maybe you've heard of that before. Oh, what's that? What engine's in that truck? Oh, it's got a 350 in it. Well, 350 is talking about its cubic inches of displacement. And if you know engines, you might know that what its equivalent is in centimeters cubed, cubic centimeters. So if you were to take 350 and multiply it by this 16 number, you get 5,735 cubic centimeters. If you know your metric system, you know that 1 cubic centimeter is equal to 1 milliliter. Maybe you can see that. Okay, so 5,735 cubic centimeters is equal to 5,735 milliliters. And oftentimes we talk about engine displacement in terms of liters. So we would call this a 5.7 liter engine. So a 350, which is in cubic inches, popular Chevy truck engine, is, not that they didn't use it in cars, but I'm just in general, it's the same as a 5.7 liter engine. So maybe you've heard of that. So a lot of times, like, you know, if you open up the hood of your car, you'll see it written on there, its size. So, you know, you might see something like 3.3 or 2.8 or 3.8, or sometimes they write them in cubic centimeters, so they'd be like a 3,800. Maybe that's confusing to you, but maybe some of you are making some sense of that. So that's just kind of a idea of how cubic inches and cubic centimeters and their relationship and how that relates to engines. Anyway, so I think this video is probably long enough. So I'll do the 10.5 explanation in a separate video.